All right, class. Sorry that took a little while. Sometimes when I'm trying to turn on the document camera, for me, it shows it in a mirror reflection, like a reverse mirror reflection. And so although you can probably see it like right side, for me, it's reverse and it's everything's like backwards. And so I have to kind of play with the machine a little bit until it's set up right. So it's set up now. I can see this here clearly. All right, so I'm going to go over and record the lesson 1.3 for the co-rec course. And then there's just 2 pages, 5 and 6. And then after I do that, then there's some recommended take-home sheets that you can work on page 7 and 8 for extra practice. And then you should check your own answers on page 78 of your co-rec workbook. You can see down here they have a take-home answer sheet for 1.3. That way you can check your work. All right. So let's take a look at 1.3. And it says fill in the blank. So commutative property of multiplication. So the order, the position of the numbers, the factors. Okay, in multiplication can be changed without changing the end result. Okay, so like for example, number 1, 7 times 4, these are called factors, is equal to 4 times 7. Those numbers are called factors. Okay, and that's why we wrote that in over here. So these are the numbers, they're called factors. In the previous lesson, 1.2, we were adding numbers. Those were called add-ins. These numbers are called factors. And notice how the position of the numbers change. See how you have 7 and then 4, and then see how the position of the numbers change. See how they swapped it, they switched it, and now it's 4 and 7. So when that happens, that's a commutative property. And this is of multiplication. I'm going to put a little X here for multiplication instead of writing that out. And also the left side does equal the right side because 7 times 4 is 28. And 4 times 7 is 28. Okay. So that's how you show your work. And also, we should also put a justification. Why? How do you justify to somebody that this is commutative property of multiplication? And this is because the position of the numbers 7 and 4 changed. Okay, yeah, so it changed, it got swapped to 4 and then 7. Okay. All right, now if we look at the second page to see if there's any other commutative property, let's take a look at the second page. And if you take a look at number 6, 6 times 9 equals 9 times 6. So this is also an example of commutative property. So I'm going to do a COMM here as an abbreviation, commutative property of multiplication. And again, this is because I'm going to do B/C for because the numbers 6 and 9 changed position. Okay. And you might need to look up 6 times 9. You have a couple of multiplication charts. You have a large 30 by 30 that was provided in your workbook. And then you also have the small 12 by 12. So if you just wanted to look up and double check 6 times 9, you can go across here. 6 times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. So 6 times 9, you can see, is 54. In case you need to look that up. Okay. And it's good to use this course to learn or memorize your multiplication facts, because if you have to take college algebra, you do have to learn how to factor. And what's helpful for students to learn how to factor is that they're really fluent in their multiplication charts. Okay. All right. Okay, now, so that takes care of that. And the left side equals the right side. Okay, let's go back to a new definition. The associative property of multiplication. So here we stress that the arrangement, okay, the grouping. So I like to stress the arrangement of the numbers in multiplication can be changed using grouping symbols. Without changing the end result. So if we look at number 4, look at number 4. So notice that the position of the numbers are not changing. Notice if I call out 3, 4, 8 on the left side, and notice how the position of the numbers remains the same. See, 3, 4, 8. So I cannot call this out as commutative property. I cannot. But that's why we're looking now at associative property. And look at the parentheses. Look how the parentheses are wrapped around the last 2 numbers. And then see how now the parentheses are wrapped around the first 2, the front 2 numbers. That is associative property. Multiplication, excuse me, and then I'm going to say because the arrangement changed. Okay, the arrangement changed. So the parentheses, and I'm going to put, instead of writing it out, I'm going to do this. The parentheses are wrapped around the last 2 numbers and the first 2 numbers. Okay. So these parentheses are wrapped around the, and I'll highlight that, they're wrapped around the last 2 numbers and the first 2 numbers. So that's why we call that the arrangement has changed. Okay. And then I'm going to show that the left side does equal the right side. So if I start with what's inside parentheses, 8 times 4, I should say 4 times 8 is 32. So that's 3 times 32. And then if I figure 3 times 32 on the side here, 3 times 2 is 6, 3 times 3 is 9. So it looks like that gives us 96. And then if I check or test the other side, 3 times 4 is 12. And then we're figuring 12 times 8. So if I calculate that here on the side, 12 times 8. 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. Yep, so we get 96 equals 96, all right? Okay, so that's associative property. And if we look for associative property on the other side of the page, and also if I'm ever going too quickly or too fast, you can always pause the video where you're at. Just pause it until you finish writing everything down or thinking about it. And then you just start up the video again if I ever go too quickly. But on the next page, if I'm looking for another example of associative property, I do notice that here on number 9. If you look at number 9, look how the commutativity remains the same. The the position of the number stays the same. Look how you have 795 and then 795. So this cannot be commutative property. The position of the numbers is not changing. But what's happening is the arrangement is changing. The parentheses are arranged around the last two numbers, and then they're rearranged now around the first two numbers. Okay. And that's called associative property. Excuse me. And this is because the arrangement has changed. Okay. And so the parentheses, I'm going to just do this. The parentheses are wrapped around the last two numbers and the first two numbers. And then if we figure the math on this, if I look at what's inside parentheses, 9 times 5, that's 45. And I've got this times 7. So on the side here, I'm going to do 45 times 7. 5 times 7 is 35. Carry the 3. 7 times 4 is 28. 29, 30, 31. So it looks like that's 315. And if I look at the right side, I've got 7 times 9. So you might want to double check that on your multiplication chart. 7 times, go all the way out to 9. And you see that it's 63. 7 times 9, see, is 63. And then times 5. So I do on the side. 5 times 3 is 15, carry the 1. 5 times 6 is 30, plus 1 is 315. See how that matches? Okay. All right, so that's associative property. Okay, next vocabulary word is multiplication property of 0. So that says that the product of a number and 0 equals 0. So I'm getting the choices from up here. See these answer choices up here? So yeah, so we already used factors, we already used grouping symbols, and now we're using 0. So the product of a number and 0 equals 0. Yeah, so any number times 0 is equal to 0. So it looks like we see that on number 2. See right here, 1 times 0 equals 0. So yeah, 1 times 0 is 0, and 0 does equal 0. So that's called the multiplication property of 0. And then if we look at the next page and looking for property, multiplication property of 0, it looks like we see that on number 7. See, 4 times 0 is 0. Multiplication property of 0. Do a little shorthand here. Okay. And then it looks like what's remaining is one more property. And that looks like it's the multiplicative identity. The product of a number and 1 equals the number. So the number 1 is called the multiplicative identity. Okay. So basically any number times 1 is itself. Any number times 1 is itself. So we see that happening here on number 3. See, 1 times 1 1 times 1 is 1, and 1 equals 1. But you've got that any number times 1 is that any number. And so this is multiplicative identity. Okay. And if you want to like a justification, because we put justification on the other ones, you could say because any number times 1 equals itself. Excuse me, this is B/C for because. Okay, because any number times 1 equals self. Okay. And over here, I'm thinking about, I didn't put a justification for this one, multiplication property of 0. But I think we just didn't write it. I could say BC because any number times 0 equals 0. Okay. And if we look at page 6, I think let's see what's left on page 6. Number 8's left. 6 times 1 equals 6. Yeah, so 6 times 1 is 6. And yeah, 6 equals 6. Yeah. But there you've got that number being multiplied by 1. So that's multiplicative identity. And that's because any number times 1 equals itself. Yeah, so when you did 6 times 1, you got itself back, you got back to 6. Okay. Okay. And again, if you ever need to just pause the video, if I'm going too fast, you can pause it and then just start it up again when you're done writing. But the remainder idea is this idea of doing distributive property. See this directions, evaluate the expression, but see in bold, it wants you to use the distributive property. So let me show you that first, and then I'll talk about the check. So in the distributive property, I like to use arrows. 8 is the distributor. So think of 8 as the distributor. And so you're calculating 8 times 7, okay, which is 56. If we look that up here, 8 times 7 is 56, okay? And then looking up 8 times 12. And it's probably a good idea to do this so you can remember that we did 8 times 7 and then to do this. Remember that we got 8 times 12. And 8 times 12, 8 all the way to the end times 12, see, is 96. And then when you add those up, the 56 and the 96, when you add those up, and these are add-ins, it doesn't matter here which one you put first when you're adding them, but 6 and 6 is 12, carry your 1. 9 and 1 is 10, plus 5 is 15. So it looks like that's 152. And that's showing your work using what they call the distributive property. Okay. Now, if you want to do a check, we recommend you do a check using the other method, the other way to get there's another way to get 152, and that's using Pemdas. And you can use that if you want as a check, okay? But for sure, you've got to show the distributive property because see, they want you to use that, so you got to follow directions. But if you want to check your work, then check it using Pemdas. So I rewrite the problem again. And the PEMDAS, the P stands for doing operations inside parentheses. P stands for doing operations inside parentheses. So you want to do 7 plus 12, and that should be 19. So now you got 8 times 19. And then you're going to do the M, because the E stands for exponents, and we don't have any exponents, so you got to skip that. But then the MD, you do those from left to right, whichever comes first, multiplication or division. So you got to be flexible with that. But in this problem, you don't have multiplication and division, you only have multiplication. So that's why you do the M next, which is 8 times 19. And on the small chart, it goes off the small chart because this is 12 by 12. But in your 410 workbook, they gave you a bigger one, a 30 by 30. So if you look up 8 times 19, sometimes I like to use rulers. We use rulers a lot in statistics because we're always looking up like areas underneath curves. Using the standard normal table. So I'm used to using rulers for those tables. But if I do 8 times 19, 8 times 19 is right here. And you see, it looks like it says right there that it's 152. 152. All right. Okay. So that you feel comfortable that you got the end result. This is using distributive property, showing your work this way. And this process here is showing your work using PEMDAS, okay? So as a check, it's okay to do it that way. As you're just checking, then you already have what's required, which is distributive property, right? Okay, and then there is one more example of that over here, number 10. Where they want you to use the distributive property. Okay, so normally what I would advise, like if you're looking at the video, I would recommend like right now, like you just stop the video or pause it, and then you work it out and then like check it, just like we did number 5 over here. And then when you're done, then resume the video, restart the video, you know, and then check your work. That's what I would recommend you do. Okay, and so now I'm gonna work this out. So I'm gonna do the distributive property. So I'm gonna do 9 times 5. Show some work, which is 45. And then I'm gonna do this other distributive property, and I'm gonna calculate 9 times 11, which is 99. And then I'm gonna show some computation and add those both up. And so I'm gonna use my fingers. I have 9, 10, 11, 12, 13, 14, carry the 1, 9 and 1 is 10, plus 1 is 4. So this looks like this ends up with being 144, okay? Now to check it, I can check using PEMDAS just to feel comfortable that we got the same answer. So I have a 9 parentheses 5 plus 11. And in the PEMDAS, you would want to calculate operations that are inside parentheses first. So that would be the operation of addition. 5 plus 11 is actually 16. So that's 9 times 16. And then you would want to, there's no exponents. And then you go next to multiplication. And you do have multiplication right here with 9 times 16. So if you look that up on your multiplication chart, 9 times 16 looks like that's 144. 144. See right there? 144. All right, and so you see these are the same results, so you feel comfortable with that. And then this is using distributive property. This is using PEMDAS. Okay. All right, so that concludes my lesson for 1.3. Okay, and then just remember about the take-home sheets. You can do this for extra practice and then check your work using the back of the co-reg. They have the answer keys there in the back. Okay. Thank you.